Have you ever pondered why the Earth's atmosphere is remarkably different from other planets in our solar system? The answer to this cosmic conundrum lies in the unique combination of elements and conditions that make up our planet's atmosphere. Our atmosphere, this invisible yet critical layer of gases enveloping the Earth, is a complex, dynamic system. It contains a unique blend of nitrogen, oxygen, argon, and a smattering of other gases, all held in place by Earth's gravity. This delicate balance of gases is what enables life to thrive and flourish here on Earth, a scenario that is strikingly different from what we see on other planets in our solar system. Now let's consider our celestial neighbors for a moment. Mars, for instance, has a thin atmosphere primarily composed of carbon dioxide with traces of nitrogen and argon, and it lacks the oxygen essential for human life. Venus, on the other hand, is swathed in a dense, toxic atmosphere, also dominated by carbon dioxide with clouds of sulfuric acid, a far cry from the breathable air on Earth. Then there's the gas giants, Jupiter and Saturn. Their atmospheres are comprised mostly of hydrogen and helium, akin to the composition of the Sun. Beyond these giants, Uranus and Neptune present a frigid, harsh atmosphere, with methane contributing to their blue hue. So what makes Earth's atmosphere so distinctive? It's the precise cocktail of gases combined with the right distance from the Sun, among other factors. This unique mix not only supports life, but also creates the conditions for weather patterns and climate, shields us from harmful solar radiation, and even plays a role in the stunning natural light displays of auroras. Understanding the distinctive characteristics of Earth's atmosphere sets the stage for a deeper exploration. Stay tuned. To comprehend Earth's atmospheric singularity, we must first decode its composition. The Earth's atmosphere is a complex mixture of gases, each playing a crucial role in sustaining life and maintaining our planet's distinctiveness. Primarily, our atmosphere is made up of nitrogen, constituting about 78%. Nitrogen is a silent yet essential player, serving as a diluting agent to prevent rapid combustion and fires. Next, we have oxygen, making up roughly 21%. Oxygen is the breath of life, quite literally. It's what we breathe in to keep our cells alive and kicking. Argon, a noble gas, accounts for nearly 1%. Though it doesn't react with other elements or compounds under normal conditions, it plays a role in our atmosphere by filling up space. The remaining trace gases, including carbon dioxide, neon, and helium, despite their minuscule presence, have significant roles in temperature regulation and the propagation of sound. This unique cocktail of gases not only supports life but sets Earth apart from its celestial neighbors. The Earth's atmosphere does much more than merely hold the air we breathe. It acts as a silent guardian, a life-preserving layer that shields us from the harsh reality of space. This is a role that it plays so perfectly, and yet it's something we often take for granted. Let's start with the Sun. Our star is a constant source of energy, but it also emits harmful solar radiation, including ultraviolet rays. Without the Earth's atmosphere, these harmful rays would reach the surface unimpeded, causing significant damage to living organisms. But our atmosphere, with its unique composition, absorbs and scatters much of this radiation, allowing only a fraction of it to reach the surface. This is why we can bask in the sunlight without worrying about the harmful effects of solar radiation. Then, there's the matter of temperature regulation. The Earth is in the Goldilocks zone, which means it's at just the right distance from the Sun for life to exist. But it's not merely about the distance. Our atmosphere plays a crucial role in maintaining this delicate balance by trapping some of the Sun's heat. This greenhouse effect, despite its negative connotations in the context of global warming, is fundamentally what keeps our planet warm enough to sustain life. And finally, the atmosphere sets the stage for weather phenomena. Rain, snow, wind, thunderstorms, all these are products of the Earth's atmosphere. The atmosphere's ability to hold and move water vapor is responsible for our planet's diverse climates and weather patterns, making Earth a dynamic and vibrant place to live. In essence, the Earth's atmosphere is a complex and finely tuned system, a life-sustaining layer that protects us from the harshness of space and makes our planet habitable. It's a feature that sets Earth apart from other planets in our solar system. Our atmosphere, thus, serves as a protective shield, a feature not commonly found on other planets. With the understanding of Earth's atmosphere, how then does it contrast with those of other planets? Let's journey through the solar system and make some comparisons, starting with Mars. Mars's atmosphere is vastly different from ours. It is composed mostly of carbon dioxide with traces of nitrogen and argon. But the most stark difference is its thinness. The atmospheric pressure on Mars is less than 1% that of Earth's, meaning it lacks the density to retain heat or support liquid water on its surface. Thus, the red planet doesn't have the necessary conditions to sustain life as we know it. Next stop, Venus. Unlike Mars, Venus has an incredibly dense atmosphere, 90 times denser than Earth's. It's predominantly composed of carbon dioxide with clouds of sulfuric acid. This dense cover creates a greenhouse effect so intense that it makes Venus the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. The extreme temperatures and corrosive atmosphere make Venus an inhospitable environment for life. Our final stop is the gas giant, Jupiter. Its atmosphere is composed mainly of hydrogen and helium, mimicking the Sun's composition. But don't let that fool you into thinking it's a sunny paradise. Jupiter's atmosphere also contains traces of methane, water, ammonia, and even neon. The planet is known for its Great Red Spot, a storm larger than Earth that's been raging for centuries. Jupiter's high radiation levels and lack of a solid surface make it a harsh environment for life. In comparison, Earth's atmosphere, with its life-sustaining oxygen, protective ozone layer, and balanced greenhouse effect, seems almost miraculous. The presence of nitrogen and oxygen, the shielding from harmful solar radiation, and the ability to retain just the right amount of solar heat all make our planet the only one in the solar system known to support life. The stark differences in atmospheres across our solar system underscore the uniqueness of our home planet. The Earth's atmosphere is indeed an anomaly in the vast expanse of space. This isn't just a poetic sentiment, but a scientific fact. Our atmosphere is a complex and intricate system, unlike any other in our solar system. It's a delicate balance of gases, pressure, and temperature, the perfect recipe for life as we know it. Let's take a moment to recall the main points that make our atmosphere unique. It's composed of a blend of gases, primarily nitrogen and oxygen, with traces of argon, carbon dioxide, and others. This mix is quite different from the atmospheres of other planets, which can be dominated by one or two gases such as carbon dioxide on Mars or helium and hydrogen on Jupiter. Moreover, our atmosphere has a layered structure, each with its own unique characteristics. The troposphere where we live is teeming with weather activity. The stratosphere, on the other hand, contains the ozone layer, which shields us from harmful solar radiation. Remember the Goldilocks principle? Earth's atmosphere is not too thick, not too thin, but just right. It's dense enough to protect us from meteoroids, yet thin enough to allow light and warmth from the sun. This is in stark contrast to places like Venus, where the thick atmosphere creates a greenhouse effect, or Mars, with its thin atmosphere that offers little protection. And let's not forget the role of water. Earth's atmosphere is the only one in the solar system that can support water in all its forms, solid, liquid, and gas. This is due to the precise balance of temperature and pressure, which allows for the water cycle, a fundamental process in supporting life. These unique aspects of our atmosphere, from its composition to its structure, from its density to its interaction with water, all combine to create the perfect conditions for life. These elements have worked together over billions of years, evolving and adapting to make Earth the living planet it is today. So, next time you take a breath, remember you're experiencing the magic of Earth's unique atmosphere, a rarity in the cosmos.